My name is Mikael Eriksson and I've been in Max Lab for ages. I think I've been here for 47 years or something like that. I've been a professor in accelerator physics and then I became the machine director, and before that I was in charge of the accelerators at Max Lab, and before that I was in charge of the high energy machine Lucy, which was an electron synchrotron in Lund, but that was in the late 60s. You know, after the Second World War, all industrialized countries they were shocked by the atomic bomb and nuclear power, so they started research in nuclear physics. And in Lund, pretty impressive machine for nuclear physics were built, which was called Lucy, Lund University Synchrotron. And that was put down in 1972. And then we started to construct a new cheap machine which the faculty should afford to run themselves. That was the start of the Max accelerators. It was tough because it was underfunded. Well, I wouldn't say underfunded, I would rather say not funded at all. So I worked as a consultant for a company making accelerators in Uppsala, Scanditronics, and the people here made lots of funny machines for industry. And after a long time, it's finally went into operation. I think it was 1985. And that was originally only for nuclear physics. But my supervisor, he was coming from US and said that people are crazy about something called synchrotron radiation there. And we also had a professor from Gothenburg who made some synchrotron radiation work at Lucy. And so we started to construct a machine which not only was for nuclear physics, but also a synchrotron radiation source as well.
So my name is Stacey Sörenssen and I am Vice Director for Research, and I also have responsibility for the university's research infrastructures, which Max 4 is one of them. It must have been about 1990 that I first visited Max. I was in Sweden as a postdoc, and one of my two projects was to do an experiment at Max 1 on a beamline that had been built but never really used. So it turned out that part of the project was also to get the beamline working. So there was kind of a little core of people, but there was a very strong connection to several Swedish universities, and there was a real sort of pioneering spirit at the lab.
It was not a very good machine. It was as cheap as possible. Everything was homemade, magnets, power supplies, control system, everything was made by 7 people, including people in the workshop, secretary, etc. And but we had crème de la crème scientists in Uppsala in photoelectron spectroscopy, Siegbahn, and they started to make very good scientific papers, produce that. So even if it was not the best machine in the world, they published a lot.
At that time, I think Max also realized that there was a potential to do something more than just to work on kind of an old machine where you could easily, open up the wall because everything was built out of blocks, but also to really come up with a concept for a laboratory that would have a higher, let's say, scientific profile, or more ambitious. And that's what led to the Max 2 ring, which was, I think, a really huge leap at that time. Max 3 was a way to test a concept. It was really, I think, a prototype, test of a lot of different concepts and principles. And it wasn't really ever thought of as a ring that would be serving users. But okay, it turned out it could deliver something that they couldn't deliver at the other rings, so then that was used. But mainly it showed this concept of this multi-bend achromat, so this type of magnet construction that was then scaled up for the MAX 4 facility. But even though the leap from MAX 1 to MAX 2 was really huge, the leap from the old MAX or the MAX lab to MAX 4 is so much bigger that it's, I think, almost impossible to really imagine how big that leap is. And I think it's brought a lot of big challenges with it as well that I think all of us are really trying to work with today. And also the fact that ESS is part of the landscape is another aspect which makes it much more political than it was before. But I think it's more fun to still focus on the science, and it's probably been a longer road to go from MAX Lab to MAX 4 than most people imagined.
I couldn't dream of this development, honestly. I couldn't dream of that. I mean, imagine yourself making the soldering work and hardware work, and then it's grow. But what has made it grow is not, in fact, the machines. It's synchrotron radiation science has exploded globally. We are riding on a wave, so we are lucky in time to ride on this wave. So of course things must have been working out, of course it must function, and the scientific community in Sweden and the Nordic countries, northern Germany, is very well established. The danger is, of course, if we start being content with what we have, because it's the first sign of declination. So we have been constructing a new major machine each decade, and I hope we'll see the next one 10 years from 2015, when the MAX 4 ring went into operation. This area of synchrotron radiation is still expanded. I think we have something like 50,000 users in Western Europe only, and it's still growing, and complemented by free electron laser and other things. It's lots of things to do.
Since I have seen MAX 4 from a perspective, so watching it historically, I have obviously a very warm feeling for MAX 4, but I can also mention that as a university that's the host of a facility like MAX 4, we're amazingly proud that MAX 4 has come so far, and we are really proud to be the host of MAX, and we see this as, I think, one of the best parts of the university.